Let f of x equal -4 sine x times cosine x. Here we have the product of two trig functions, and we need to find a derivative based off of that product. So let's see what we can do here. In order to evaluate the derivative of a product, we use the product rule. And the product rule says, I'm going to leave the -4 off to the side and just concentrate on the two functions multiplied. So I'm going to take the first times the derivative of the second. Oops, not negative cosine, but negative sine, because it switches to sine. And then plus, for the product rule, the derivative of the first, which is cosine x, times the second, which is also cosine. Okay. Now this is a perfectly fine derivative. You could leave it right here, but it looks like there might be some simplification we can do, and it's up to you if you want to do that or not. It's in this case, I could make this negative sine squared x plus cosine squared x, or potentially multiplying in the negative just to get rid of that, for sine squared x minus cosine squared x. And this is a perfectly fine answer. One thing that's tempting to do is to rewrite it as like sine squared plus cosine squared would be 1, of course, but that's only if they're added together. If they're subtracted, there is another trig substitution that could be done. So there is another form of this that could be simpler, but it's really not necessary to do trig substitutions to make things simpler. Like this is a perfectly fine representation of the derivative.